Assalamu alaikum dear students. Today we are going to start a new topic. Welcome to Zoom online class. Subject is Physics class 9, chapter 7, Properties of Matter. Now today's topic is stress strain Young modulus, stress strain curves, examples plus assignments. Now first we are going to discuss about the stress. Introduction. A wire elastic under tension will extend. Its extension depends on the number of factors such as the tension, its diameter, length, and the material of the wire. Suppose that a wire of length L and cross-sectional area A is stretched by a force F and the extension produced is X. Look at this one diagram and you can see that figure 10.7.10 it shows that the area force and the X cross-sectional area is shown to you. Now the info that what is the tension that in physics tension is described by the pulling force transmitted exactly by the means of the string, a cable, chain or similar one-dimensional continuous object act as a normal force is suspended strings or suspended object. Now the definition of stress. What is stress? The stress applied to a wire is defined as the force applied per unit area of a cross-sectional to produce deformation. Mathematically, we can write the stress equals to force by area of cross-section or stress equals to F by A. Unit. What is the unit of the stress? The unit of stress is Newton per meter square because the force unit is the Newton and the area unit is a meter square. That's why the unit of the stress is Newton per meter square or we say that a Pascal. Look at this one diagram. You can see that clearly that a force is applying on upward direction, downward direction and the delta L. You can see in a figure A that a delta L is there and the figure B the delta L is changed. Now look at that uniform compression and this is the tension up in upward direction and in the downward direction. The compression is the both the directions are their directions are similar to each other and have you seen that in this one diagram. Now definition a difference between the stress and pressure. Now if the we are applying a force, look at this one diagram. If the in this you can see that arrows directions that if it is the pressure, we can say that it's like a pressure, but it's not a pressure. There's a difference between the pressure and the stress. Now what is the difference between the pressure and the stress? What is pressure? Pressure is the force per unit area applied perpendicular to the surface or to which it is applied specific area. Stress. Now what is stress? Stress is defined as the internal resistive force to deformation per unit area area of cross section. Stress is developed internally all directions. You can see that it is internally develops in all direction. Pressure is exactly exerted externally. Pressure act perpendicularly but stress act up perpendicular as well as parallel in all direction. You can see this one a lost diagram that is the also in the parallel form. Clear? But pressure is only in the perpendicular and the stress is perpendicular as well as in the parallel direction. Look at this one diagram. Clear? You can see this one balloon we are applying a pressure on a one direction. Clear? Now in this diagram you can see that we are applying a pressure. You can see that a pressure is only in a one direction but stress inducts. You can see in all the yellow arrows this in a downwards direction. You can see that now F you can see this one arrow only a one arrow that it shows that a downward pressure. Now there is a difference between the pressure and the stress. Look at this this one is the area and the force is applying in upward direction, downward direction. Look at this one areas. Though the stress is the force by area. Clear? Now strain. As a result, a wire being stretched, it is under strain. Definition: strain is defined as the extension X per unit length L is called strain. Extension means how much the wire being stretched or extended from its original length. Clear? Look at this. That you are able, this is the original length. You can see that ठीक है. And if you are going to be stretched, it increase. You can see that a little bit small arrow, blue area, that increase the length after loaded apply. Clear? And this one, this is the normal area, and you are applying a force, it's going to be an increase. Now mathematically, strain equals to extension by original length, means strain equals to x by L, where the x is the extension or change in the original length and L is the original length. Now the unit of strain, since strain is the ratio of two lengths, it does not have a unit. Strain equals to x by L. Strain equals to meter by meter equals to 1. The unit of stranded length, stretched changing length, is meter. Unit of original length is also meter. So strain have no unit. Means strain have no unit. Strain is basically change in shape, size, length, area, volume per unit original ones. Simply, we can see the change in dimension per unit original dimensions. Look at this one diagram. That a large stress and the small stress. If stress by strain equals to a large strong material, small weak material. Look at this one purple color diagram, that a large strain, you are applying a force in the downward direction, and you can see that in a next one column that a change. Now the small strain, when you are applying a force from the upward direction, it's only compressed in the little bit. Now the next one is a Young modulus. Now what is a Young modulus? Modified Hooke's law. It modifies the Hooke's law. The strain produced in a stretched wire is proportional to the stress within the limit of proportionality, or stress is directly proportional to strain. Mathematically, stress is directly proportional to strain, or stress equals to constant multiplied by strain. Constant is proportionality is called Young modulus, and it is denoted by Y. Stress equals to Young modulus multiplied by strain. By rearranging above relation, we get Young modulus equals to a stress by strain. This is the formula of the Young modulus. Now, a Young modulus definition is the ratio of stress and strain is a constant called Young modulus. Simply, Young modulus is the ratio of stress to strain. The value of Young modulus depends on the material, while nature of material which is used, either wire, stress, etc. Material like aluminium, copper, brass, lead, iron, steel, etc. Young modulus mathematical relation is the Young modulus equals to a stress by strain. Young modulus denoted by Y. We know that stress equals to F by A and the strain equals to X by L. Putting the values in the stress and strain in equation 1, we get that Y equals to F by A by X by L. By rearranging that, Y equals to Fx F into L by A into X. Must keep in mind that Young modulus is defined for different materials. Means Young modulus is, if you are checking for the one material, it's different for the other material. We can see in table given in the book page number 191. Is it given into your book? Now look at this, that a Young modulus. Clear? Look at this one diagram. Now strain, the original L, and stress, when we are applying a force, the delta L is going to be increased. The Young modulus E equals to stress by strain, F divided by delta L by L. Clear? So the Young modulus can be used for the change in, you can see in the diagram. Now stress strain curves. Stress strain curves are measured by stress Tester one such machine's rock wall hardness tester. Now, stress strain curves. We apply stress is increased and the change in the length is noted. The value are then printed on graph. A typical graph for material is shown in the figure. Look at this one diagram. This is the diagram when we check a stress we are applying on this and the strain we are showing like this. Okay, stress strain curves. Graphical interruption. Here point A is the limit of proportionality. The limit up to which Hooke's law is obeyed is called the proportional limit. Point B is the elastic limit. The limit up to which point the limit up to which material shows elastic behavior. Point C is the maximum stress y which can stand without breaking. Point D is the breaking point where material breaks and becomes inelastic and exists proportional limit. Look at this one diagram. This one diagram is captured from your book and look at this one diagram. Okay? Proportional limits is given to elastic and the low breaks and others. Okay, thank you.